Hey folks, welcome to my channel Number Pen. Today we have another interesting problem in front of us. Uh, so let's take a few seconds to read through the problem. Now, let L be any tangent to the curve root x plus root y equals root k greater than 0. Show that the sum of the x-intercept and the y-intercept of L, which is the tangent, is k, right? This is the equation. So, unlike my previous videos, what I've done is I've spent a few minutes trying to solve the problem myself, and we will use this video to quickly go through the solution and how we arrive at answer to this question and solve similar problems. So, the three important observations which I want to draw your attention to: one is root x plus root y equals root k means x and y cannot be negative, right? And so that's observation number one, which means that your graph is always on quadrant one. X and Y are always within K, right? Because if X is going to be greater than K, you will see that the root of Y will become a negative number, which is not possible in the real world, right? Right. So then we have root X plus root Y equals root K, right? Which means that X and Y are always uh, within k. How do we arrive at this? Root x plus root y equals root k. So root y is equal to root x minus root k minus root x, right? So root y is always a positive number. So root k minus root x is always greater than 0. So x will always be lesser than or equal to k, right? And that's applicable for our y as well. So therefore x and y will always remain within k. And yeah, so these are, and then we have a third observation where when x equals k by 2, y equals k by 2, is one of the solutions to these equations where x and y coordinates uh, are the same, right? So with this, we draw this particular curve. I've made a rough sketch of this curve. So this orange line, what you see is the curve, and I've drawn a tangent to this curve, which is this blue line, right? And let me see if I can improve the thickness of this line. Yeah, yeah. And I'm calling this point when the tangent passes through the curve x1 y1, right? And we have been asked to prove that the sum of the x-intercept and the y-intercept of the line is k. So what do we mean by x-intercept? As we extend the tangent when it cuts across the x-axis, the distance made between the origin and the point where it cuts is your x-intercept, and the point where it cuts the y-axis, the distance from the origin to that point is your y-intercept, right? So I'm calling this x2 and y2. As you can see here, I would have marked these points as x2 and y2. So we will have to find out what is x2 plus y2, right? So that is how we are going to proceed through this problem. Now, to find out y2 and x2, all we'll have to do is find the equation of the tangent to this line, right? This blue line, which is the tangent, we will have to find the equation of this line. How do we arrive at the equation of this line? We are quite familiar at this. We know the slope of the line. We can easily, and we know one of the points through which the line passes. We can easily arrive at the equation of this line using the formula y minus y1 equals m into x minus x1, right? So that's the equation of a line passing through x1 y1 with a slope m. So what is m? M is, again, go back to our past lessons. We know dy by dx is you're the slope of the tangent through the curve. So I take the equation, I do a differential on either side, right? So root of x becomes 1 by 2 root x, root of y becomes 1 by 2 root y into dy by dx. K is a constant, so equals 0. I rearrange dy by dx here, and I get my dy by dx here, right? Now I have this, and the line passes through x1 comma y1. So at x1 comma y1, the line that passes through x1 comma y1, its equation, its slope can be written as root of y1 by x1, right? So maybe I'll probably write it. Yeah, I'll probably write it here. Y1 divided by x1, right? At the point x1 comma y1, which is nothing but these points, right? Where the curve is passing through these points. What I've highlighted here, which is here, what I've marked, right? So let's go back to solving this problem. So now we have dy by dx, and we will have to find out what is the equation of this line. So like I discussed earlier, y minus y1 equals m into x minus x1, right? So we know what is dy by what is m, which is dy by dx. So I substitute m by dy by dx, and you arrive at the equation, which is your y minus y1 equals minus of root of y1 by x1 into x minus x1. Now this is the equation of the line, right? Now what is the y-intercept? How do we arrive at the y-intercept? Now we have the equation to the line. Let's assume that the intercept is at 0 comma y2. Why 0? Because the point where it intersects the y-axis is when x equals 0, right? So we substitute x equals 0 in this equation, and we arrive at what is uh, y2, right? Which is, I've rearranged this is nothing but this equation. And similarly, we've been asked to find the x-intercept. What is x-intercept? The tangent, which is basically, I'm just going back to this diagram, this tangent intercepting the x-axis at this point, right? And the distance from the origin to this particular point is called your x2. So your line intercepts at 0 comma x2 comma 0. So I substitute the points like what we did while arriving at the exact y-intercept, and we arrive at this equation, right? So I'm going to take a minute to explain this again. Y2 minus y1 is equals to minus root of y1 by x1 into x2 minus x1, and we substitute x2 equals, we substitute x equals 0. And similarly, I have my x-intercept at a point called x2 comma 0, which means my y-intercept is 0 at that point. So I substitute 0 minus y1 equals minus root of y1 by x1 into x2 minus x1. So with this, I arrive at what is my x2 and y2 in terms of y1 x1, right? So we have two equations which I'm going to circle. One is this, which is your y2, and the other is your x2, right? So both x2 and y2 have been expressed in terms of y1 and x1. Now what is the sum of the intercept, which is what the question is asking, right? Now the question is x2 plus y2. So we sum up x2 and y2, and we get this particular equation, right? And what is that equation? X2 plus y2 equals x1 plus y1 plus 2 root x1 y1, right? There's a small mistake here. I think I got this wrong. This is x1 y1. Okay. Yeah. Yeah. So you have x1 and y1, and you have x2 and y2 in terms of x1 and y1. So you sum up these two equations, right? You sum up this equation and you sum up with this equation, right? So you have x2 and y2, you sum them up to arrive at what is x2 plus y2 in terms of x1 y1. So x2 plus y2 is nothing but x1 plus y1 plus 2 times root of x1 y1. So basically what we are doing is we have we have summed up these two equations, right, to arrive at what is x2 plus y2. So what is this? This is nothing but root of x1 plus root of y1, the whole square. And we know that x1 and y1 passes through the curve, which means that it has to be always equals to root of k. So we have a root of x1 plus root of y1 is nothing but is your root of k, and root of k the whole square is nothing but your k. So you take any point on the curve, you will uh, you'll be able to arrive at what is the sum of intercept of the tangent through this curve. So that's all we have for today on this video. I hope you had a good understanding of this particular problem, and please subscribe to my channel, and happy to take feedback from my subscribers and viewers. Have a good day. Thank you.